In this video, we will discuss the first type of trigonometric integral. The first type refers to sine raised to some power, cosine raised to some power, dx. This video is for case 2. Case 2 is when the power of sine is odd. We already discussed case 1 in the previous video. So case 1 refers to the power of cosine is odd. So either cosine has an odd power, case 1, or sine has an odd power, case 2. There is a note right here in the box. If in one integral, if both the power of sine and cosine, they both have odd power, then either case 1 is fine, case 2 is fine. Either you follow case 1 or you follow case 2. I prepare two integrals for you. So the first integral, sine is raised to the 5th power, 5 is odd. Second integral, sine is raised to the 3rd power, 3 is odd. So let's take care of the one on the left first, shall we? So we have odd power on the sine. What should we do? According to case 2, we have to factor out a sine. Okay, so let's do that. Integral, let's factor our sine. So that will be sine of 2x, and then I draw a dot. So when I see this big dot, I know that this I already factor out a sine, right? So how many, what's the power? So you have 4th power, right? So 4th power, according to the second line of integral, you have to keep a 2 inside the big parenthesis. So all right, so I will draw a parenthesis, and this must be a 2. So sine square 2x, that must be a 2. So that means the other number must be a 2 as well, because 2 times 2 is equals to 4. 4 plus 1 is equals to 5. And then the cosine, in this case, we do not change the cosine, so that stays as a cosine square 2x. And then you have to use the fundamental identities, right, to rewrite the sine square as 1 minus cosine square. All right, so let's do that. We have integral sine of 2x, and then times the sine square becomes 1 minus cosine square 2x square, and then times cosine square 2x, so dx. So this line is long, so it looks like we have to we cannot show both integral on the same page. Okay, the next step, according to the cookbook recipe, I have to do a u substitution, and this time I have to let u equals to cosine x. So du is equals to what? Oh, not cosine x, cosine of 2x, because the given problem use a 2x. And then du is equals to negative, the derivative of sine is cosine. The derivative of cosine is negative sine. So you have sine of 2x, and then use the chain rule. There is a 2 in front of the sine, right? Chain rule. And then you have 1 divided by negative 2, sine of 2x du equals to dx. And then you are going to do a change of variable, so you will be putting this dx over here. Okay, so after the change of variable, the sine of 2x will cancel with the sine of 2x in front of the integrand. So you have integral sine of 2x, and then you multiply 1 minus, so that will be u square, right? 1 minus u square, and then there is a square. The cosine square becomes a u square. And then the change of variable, you have this piece right here, 1 divided by negative 2, sine of 2x du. And then of course we can do a cancellation, so get rid of the sine 2x and the sine of 2x. So the du, we have to check the integrand has u only. And then the next step, you have to open up the 1 minus u square. So after you open that up, that becomes 1 minus 2u square plus u to the 4th. So these things now is right here. You open up the second power, and then times u square du, and then you distribute the u square. Oh, I missed something very important. I missed the negative 1/2. Where should I put the negative 1/2? So let's put the negative 1/2 right here. So let's put the negative 1/2 right here du. And then the next line, maybe I can factor out the negative 1/2 and then do a distribution, u squared minus 2u to the fourth, and then plus u to the 4 plus 2 is 6, and then du. I missed my integral symbol. So this is my integral symbol. So now I am ready to integrate. I have negative 1/2 and then 1/3 u to the third minus 2 over 5 u to the fifth plus 1 over 7 u to the seventh. And then you put the u back, so you let the u equals to cosine of 2x. And then you can distribute the negative 1/2 simultaneously. So you have negative 1/3, and then you have cosine 2x to the third. Okay, so you can put it like this: cosine to the third power 2x, and then plus 1 over 5 cosine to the fifth power, and then 2x, and then minus 1 over 14 cosine 7th power 2x, and then you don't forget you have the plus c. So this is the final answer. All right, so that's the first integral, and then we have one more to go. So let's take care of that right now. The next integral we have is the one over there. So it's the integral of the square root of cosine. So square root means 1/2 power. So small n, the n equals to 1/2, and then times sine raised to the third power dx. So the power of sine is odd. So this is a case 2 problem. So let's bring this integral down here. We have the integral of the square root of cosine x times sine to the third x dx. According to the cookbook recipe, I have to factor out a sine. Okay, let's do it. So I'm going to do a factor sine of x dx, and then we do not touch the cosine, and then this we must have a square inside the parentheses, so that will be sine square x. Do I still need a power for this big parenthesis? The answer is no, because sine square times sine to the first is equals to the third power. So if you want to put a number right here, the number will be just a 1, or you don't put anything in there. And then according to the cookbook recipe, we have to rewrite this sine square as 1 minus cosine square x, right? According to the fundamental identity you study in trigonometry. So that is the square root of cosine x, and then parenthesis 1 minus cosine square x, and then times sine x dx. And then according to the cookbook recipe, you have to let u equals to cosine x. So du is equals to negative sine x dx, and then you have 1 divided by negative sine x du equals to dx, and then you do a substitution, and then you do change of variable. So that will be u to the 1/2, 1 minus u square, and then times sine of x multiply 1 divided by negative sine of x dx. So I just did a change of variable. I replaced this dx over there. And then you do a cancellation, get rid of the sine of x. So you have du this time. I wrote a mistake. So this is not dx. This is supposed to be du. So I have a du. The u is the only independent variable. And then you distribute the u to the 1/2. So that is u to the 1/2 minus 1/2 plus. There is a negative 1 in there. So I should keep the negative 1 in there. We have 1/2 plus 2, so that is equals to 5 over 2, u to the 5 over 2, and then du. Let's just distribute the negative 1 as well, so negative u to the 1/2 plus u to the 5 over 2 du. Okay, so let's integrate. And then you have u 1/2 plus 1, that is a 3 over 2, reciprocal of that 2 over 3, and then plus 5 over 2 plus 1, that will be a 7 over 2, and then reciprocal. Okay, so looks like the integration is done, and then all I need to do is I put the u back, right? So that is equals to negative 2/3. We have cosine x raised to 3/2, and then plus 7 over 2. We have a cosine x raised to 7 over 2, and then you add a c to it. So this is the final answer of this integral. Alright, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support. I will see you all in the next video. Signing off for now.